So we are in the breakout sessions for Atom, and this session is going to be about data-driven analysis using Atom. And so this will not be an end-user training. We are going to be kind of talking high-level about Atom. And for those of you who don't know me, my name is Robin, project manager with Deccan for 4 years. And I have Brian here with me also. So he is a data analyst that builds the applications. And when I get stuck on questions that I can't answer, I will defer to him. OK, so today we're going to be talking a little bit about what is Atom, how it works, and not that we're going to get into any of the back-end tables, but just enough so that you have the, to give you the confidence as to why you should believe in the results that Atom will give you. I'll give you some examples of some analysis, and then we're going to talk about some new features. And I have Q&A at the bottom. However, this is supposed to be an interactive session. And so as I'm going through any parts and pieces of this presentation, if you have any questions or would like to share some information or you would like more details, please just let me know and we'll certainly have a discussion about it. So what is Atom? Atom stands for Apparatus Deployment and Analysis Module, and it allows you to, via a score sheet and a color-coded map, represent your performance across your service area or certain parts and pieces of your service area. It allows you to do what-if calculations, so that if you say, what if I do this, it will calculate and give you new scores and new color-coded map. And I will go to a quick demonstration here. All right, so who here has not ever seen our Atom application? Okay, all right, so most of you have some awareness to it. All right, so this is what Atom looks like. As I mentioned over here on the left, I don't expect you to be able to read any of these scores, but they are response criteria, and response criteria meaning we're measuring the performance of a certain capability. So my first engine en route to on scene, my first unit dispatch to on scene. So any capability you'd like us to measure in your deployment between any two timestamps that are available in your. That's what's on the score sheet, and we have a scenario name. And when we deliver Atom to you, it's always based on the most recent 1 year's CAD data that we've been given from you, and we calibrate an Atom for you based on that. Really quick, you do see over here a little tab that says CAD Analyst. CAD Analyst is our what is reporting tool. So I'll pop over there real quick. CAD Analyst is an important part of Atom because we can't build Atom without your CAD Analyst. This is going to give you all of the performance times in terms of what is. So this is CAD timestamps, and Atom is the what if. Allows you to do predictive analysis. So you have a score sheet and your color-coded map. And as you look at these response criteria, you can click on the interactive number of, this is a 6-minute, 51-second average time toward a time target of 5 minutes and 30 seconds. And when I click on that, the map updates and tells you the zones in which you're performing well and not performing so well. And then, of course, over here is the legend that tells you the time segments for each color coding section. Okay, so we'll go back. So CAD Analyst is important, as I mentioned. We need to know how you're performing today in order to build a base model in Atom that you can begin your deployment changes with and determine what impact it has on your response times. Okay. Going back over to Atom, so you see that you have response criteria built out into incident type groups, or maybe you don't. So This says response criteria for EMS on alpha calls. These are Bravo calls. These are Charlie calls. And within them, you're sometimes measuring the same capabilities because, of course, a unit, an engine, or a rescue may travel and perform different on low priority medical calls versus high priority medical calls. So we do have the ability, and we require the ability to separate those out in ADAM so that you can tell the difference. And ADAM is meant to be used as a tool to optimize your deployment. Find out where is the best place to put a new unit, place a new station. So most of the time, clients will want to look at this decision based on either the highest priority medical calls or your structure fire calls. Not all the time, but that's most of the time. So we have to know how your units are performing on those specific incident type groups, and so we can tell you where the best location was. So I'll just kind of take you through a sample of how a decision maker might use ADAM to look and solve a problem. So I'm looking at my score sheet here, and I'm going to look at my first engine on scene or dispatched to on scene for EMS echo calls. So they're high priority calls. I see that my time target is 6 minutes and 30 seconds, and we're performing at 6:25. And our performance is 62.36%. So I want to see what that looks like. And I see, well, okay, it's pretty obvious because ADAM provides this color coding, very intuitive format for me. And a couple of things jump right out at me. I see that there's large red sections up here. My first instinct might be I need to add another engine here, or maybe I need another station over here. However, there are additional tools that ADAM brings to the table, and I might want to, first of all, look at what my workloads are. So I can click over here, look at my EMS-E, my echo workloads, and when I do that, I get another view of this problem. I can see that there are no EMS echo calls happening here, so my first gut instinct to maybe I need more resources there, ADAM has told me that's probably not the right thing to do. Maybe I need to dig deeper on the situation here. Okay, so looking at workloads is one of the options. So but I do see that there are a lot of workloads for EMS echo calls down in this area. So let's just fast forward and say, you know what, this is a good spot. We have land that's available in this area, and we feel like it's a good spot to place a station since we know EMS medical calls are a high priority for us. So what I can do with ADAM is say, tell me what would happen to my response times if I were to place a station in this area. And so all I have to do is just kind of go through this really quick, is click on the map where I want to place it and say I want a new station and I want a new unit, and I tell it it's an engine, and I give it an engine capability, and there's a new engine there. So what we have to do is press the analysis button, and we won't do that because that can take some time, but I will bring up a new scenario. So we were at 6:25, and I added a new station here. So now I have a scenario that has my current deployment as of today. I've added a new station in this area. I've added an engine to it, and now I can see that my response times have improved, and by how much. So that might be some good information for you to have. You can go back and say this is exactly this is the predicted improvement if we added a station at this location. But you might want to know more about the impact, the overall impact. So you can also compare this new scenario of this station in this area to your current situation. So let's just take a look at what Adam can tell us about the improvements or the lack of improvement based on a specific scenario option. So I've put these two scenarios together, and I've asked Adam to tell me what the comparison is. I can very quickly see that this, when I added this station with a new engine in this area, and I just have to make sure I'm on the right criteria, yes. So it has given me a positive effect, not only just in the area where I have placed the unit, but there we talked about, the keynote speaker talked about a ripple effect. This is really showing that there's a ripple effect. So a decision maker could look at this, and maybe they were only concerned with this particular area where they were placing the new station. If they were not looking at the overall area, they would miss the big picture of all of the ripple effects. So you've added a new engine here. It's relieved the workload from engines all over and provided a positive improvement in a lot of areas. Any questions on that so far? Okay. All right. Yes. Yes. The target times? Okay, so the time targets are set by you, by the client when we do an initial build, but they can be changed for any analysis. So say for instance, you didn't have 1710 time targets built into your application, but your chief comes to you and says, hey, how are we performing to 1710 time standards? You can go into the application and change the time targets for a particular scenario and find out. Yeah, so.
Robin, if I can add something?
Yeah.
So can you, if you can go back to the map.
Yes.
So you also mentioned percentiles. So essentially what Adam does is, well, we can measure things in three ways. So we can measure the weighted average, which is the incident average. You see there. There's the incident percent, which is essentially number of incidents that beat that time target that we put in. And you mentioned percentiles, which we can also add in here. So for this demo, we don't have it in here right now. But it's pretty, so if you go back to the CAD Analyst tab real quick. So we can just add a couple more things, and we can also have the percentile on, in addition, in Adam, yeah. It's just with Adam, we have to do a little bit of work to add it in. But yeah, we can definitely do that in. For CAD Analyst, we will be dropping outliers. But for Adam, the model's kind of based on, well, it's kind of based on a normal distribution, if you know what that is. So like we wouldn't be calculating like the times of each specific instance, where we would be more like calculating a distribution. Yeah.
Excellent, great questions. Thank you, Brian.
Mm-hmm.
So in addition to looking at a scenario comparison that we saw on the map, the application also gives you some good data to base your decisions on and ask some more exploratory questions. So the application spits out for you an Excel document that says, I've compared your base scenario to another scenario, and these are all of the deltas that that it has calculated. First thing is, it tells you the incident counts by scenario, so that's a really good indicator of, are you comparing apples to apples? If you're comparing a geography that has different incident types, you might not be comparing apples to apples. So that's kind of, I view that as a sanity check to make sure that your data is good. So let's go down here real quick and look at some of the other data it gives us. It tells us that for the first engine dispatched to on-scene, we've improved our percent compliance by 5.919%. We've reduced by 11 seconds. And then it tells us the deployment, what units were at what stations for the base to the compare scenario. And then this is an important piece of data to help you with your decisions, which is the runs per day and availability from one scenario to the next. So when you add in a resource, and so we added in a new engine at that scenario, on that scenario. That new engine is picking up a projected 15.88 runs per day. So you know you will be putting that unit to good work. And As we noticed from the map, where the green spread out far into the other areas of the service area, that also checks out with what we're seeing here in terms of the availability differences. All of the units appear to be receiving some benefit in terms of, so the availability percent is improving, and so the scores are changing in a positive way. So that's another way to find out, when you add a resource to the deployment, who is going to get the benefit of workload relief from this particular move. So a lot of good information and data is available to you by scenario when you're moving and adding resources around. So the types of questions you can answer using the ATOM unit manager are, what happens if and let me just let this drop down here. What happens if I add a unit to a station? What happens if I wanted to take my whole deployment and all of the BLS units that I have, I wanted to see what would happen if they were ALS units. How would that impact my scores? You can very quickly make that change within the application. Brian, what? Oh, sorry. No, I'm still in scenario comparison mode. I got to unclick. Sorry. There you go. Okay. We can create a new unit. We can change a unit home station very easily on the fly through the user toolbar here. We can make a lot of changes to the deployment to get answers to the questions. What if I move this? What if I add that? What if I delete? Have to remove units from my deployment. Okay, so that kind of takes you through a typical decision-making process and how someone would use ATOM to get answers to questions about the deployment. So let's talk about what are the components of ATOM that makes this a credible resource for you as decision makers for your department. So the components that go into ATOM are number one, an operations research basis. So using that scientific methodology to answer these complex questions to deployments. And I'll go into a little bit more of what makes ATOM a more complex analysis tool than you might find of just determining how long it takes to get from the station to any point on the street. That's one piece of the puzzle for ATOM, but it's much, much more. So ATOM combines all of these components: your response zone layer, your station layer, your street layer, your deployment, and your workloads. And let's talk a little bit more about that. So response zones, if you are not familiar with that, those are these smallest squares that are in your service area. So why are these important? They can be labeled to help you to determine what happens when I have hazard or different time target classes. So I've just turned on the time target layer. In this particular demo, everything has a city time target, but you would be able to determine what would be the impact if I had different zones that had more rural time targets out here, if not every zone is held to the same time target. So we can change the parameters for that. We can also do hazards, what we call hazard zones. So if your first full alarm in the core of your city is 1 engine and 14 firefighters, but your first full alarm maybe in some of these rural areas where you don't have a hydrant is 1 engine, 14 firefighters, and a tanker. ATOM will allow you to be able to understand what the impact is by having those different requirements in different zones. So response zones are important, and the size of the zones are important to make sure that you can get effective performance halos around your stations. So that obviously the areas and zones around your stations should be green, and then gradually, as it takes longer to respond, they would turn different colors, the orange and yellow. So It can be either you can provide us response zones that we use, or we can take your first due layer or a PDG layer that you give us and just grid it out like this. And we would just typically do quarter mile by quarter mile or half mile by half mile grids.
Yeah, quarter mile. Yeah, we usually either do half mile by half mile or quarter mile by quarter mile. Yeah. Quarter mile by quarter mile. I mean, it's gonna increase the time it takes to analyze things, but generally you're gonna get more granularity. That's usually what I recommend.
And grouping zones into PDGs, and PDGs are geographic boundaries within the application. So they're typically a PDG layer is a station first due, because most of the time a department wants to know how is this station first due area performing, and how is it performing compared to another one, right? So being able to segment out the zones into specific groupings allows you to be able to, at the click of a button, call out one particular station first due area and be able to see that this is now the scores for the first due for station 5, and then get a closer look at where you're performing better and worse within that geographic boundary.
Yeah, just to add, so the PDG stands for predefined groupings, and it doesn't just have to be. It doesn't have to just be first due. We can also do well, whatever you provide. It could be like political districts, like battalions. It could be EMS first dues. Yeah, we can do a whole bunch of different PDGs. It just stands it for more like a kind of abstract grouping that you can choose yourself.
And of course, we need your station layer. And that determines the starting location for all of your units and your street network. So in order for ADAM to be a reliable decision-making tool for you, there is the street network is an important part of that. So if there are breaks in the street network, street nodes that are missing, it does impact the ability for us to be able to estimate the travel time from your station to any zone in your area. And then we need to know your deployment. So as a scenario, a base scenario, we need to know where all of your primary units are located. So what that means is we do typically not put reserve engines or apparatus that would only be called in maybe to replace that primary unit, because we calibrate the number of runs that particular unit makes and we assign it to that unit in that station. So we need to know where all of the locations are of your primary units. And workloads. So this is an important piece of the ADAM puzzle. And we get the workloads from the CAD data that we get from you to build CAD Analyst. We know then what type of workloads, as I demonstrated earlier, where we can allow you to look at the workload calculator, and for any type of incident type group, we know what the workloads are for that zone. So that's an important piece. Because we know that these units that are in high workload areas are going to be going to more calls. They're going to be less available, and the lower the availability, they are less likely to be able to take a call in their first due. Therefore, the ADAM model is going to be taking the next closest unit and determining how long it would take for that unit to get there, and putting it all into the process when it's determining its probabilities. Any questions so far? No? Okay, so in addition to that, we also have a piece of ADAM which is controlled by the analyst. It's one of the finer tuning pieces they have. Again, it's the response factors, and again, we determine this and learn this from CAD Analyst. How fast your units travel related to the street network, and what is the difference in turnout time from one unit type to the next. So we use that in order to calibrate, and I'm not sure if I'm using the right word, but when we're building the model, we know these particular set of units go out together. Typically the engine gets there first. The ladder gets there second when it's a structure fire call. When it's a medical call, maybe the rescue gets there first and the engine follows later. Whatever the data tells us is what we use in our response factors to make sure that the model that we're building for you in Atom matches the scores that we see from your own data in CAD Analyst. All right, so putting it all together for you. We take your response data, and as I mentioned just a minute ago, we determine your dispatch assignment scheme. So this tells us and you may have an idea of what a dispatch assignment scheme is, where you know an engine and a rescue go to all medical calls, or and what your first full alarm is for a particular fire type of call. We look through the historical data and find out who actually shows up in particular zones. And we determine that DAS. Now, we do that based on the data. However, if you said to us, this is our dispatch assignment scheme, and we're thinking about changing up how we're going to respond to calls. We're no longer going to send a truck and a rescue, or an engine and a rescue. We just want to send the rescue first on BLS calls and then see what happens from there. So we can force a particular dispatch assignment scheme into the application for you and tell you then what your scores would be if we forced that particular dispatch assignment scheme. So as a general rule, we use what the data tells us. However, we have the ability to work with you to tell you what would impact there would be if we change up the dispatch assignment scheme. But that's something we have to do behind the scenes. Okay. So then we look at incident volume. We know what types of calls happen in each of your zones, and we know how long, based on your timestamps, those units are committed to those calls. So we put all of that data together, and we determine those unit availabilities and the scores for your response zones based on what we put together, and we create a base scenario for you based on your actual data. And the team here works hard to make sure that the Atom scores to build your base match as closely as possible in terms of runs per day and percent compliance to the time target and average time, so that when you look between the applications from your base and your CAD Analyst scenario, they should match in terms of halos. And then that's what you use from there to make deployment changes and determine the impact, to make your decisions on where you put things based on the improvement in scores. Any questions on that? Okay. So we've talked about what happens in terms of your street network and building a model that matches your current situation. But Atom also has the ability to help you plan for future. We have clients who we build a 2040 model for, or whatever projection you're looking for in terms of population growth and how that impacts incidents. We can work those in, as well as alternate streets. If you wanted to plan for future growth and your planning department has a proposed street network that you would like us to use, we can put that into the application also. Optimizer. So in my example I talked about earlier, we had a plot of land and we knew exactly where we wanted it to go, and we thought that was a pretty good improvement, so we just went for it. So that's not always the case. Sometimes you are asked to determine what is the best place to put a resource, and it's an open-ended question. So we have a tool for you in Atom. It's called Optimizer, and it's a wizard-based type of interface that allows you to put in some parameters to answer these open-ended questions. So it allows you to say, well, okay, do you have new units you want to add? This says given number of units. Or is there a target performance score you're trying to reach and you need to know what it's going to take to get you there? So we'll just choose given number of units. Here are the response criteria that you can use to determine the best placement. And we'll just use first engine on Delta calls. And if you choose this, it says use street corner candidate locations. It will look at your street network and determine the best intersection to place this resource. So for fire departments, it would be new station locations. For EMS teams, it might be a new post location that you wanted to post up at. And if you don't check that, what it's going to do is look for the best location across your existing stations. So no new stations are available. You just have maybe a new unit you want to add, or Optimizer can reshuffle your existing resources. So you don't have money for anything new. You have your existing stations and you have your existing resources. Optimizer will help you to place those as well. So it's not like you have to have something new in order to use Optimizer. It has the ability to filter out for specific geographic areas. So if you have a station that is, maybe it's out of date, you need to replace it, and you know it's going to be in the general area of that existing station first due, then instead of asking the application to look through the whole service area, you would say, we're looking for a better location for Station 3. Let's look at Station 3's first due. And we choose that. This allows you to select either lock units to their existing stations, or if you unlock them, they're shuffled around. And you can add a unit. And then it also gives you the flexibility to say, don't consider this station as among the possible locations. So reasons for that would be apparatus that doesn't fit in certain stations. Don't consider the airport station. We already have that covered. So you have the flexibility to refine where the application is going to look to answer this question. And then we have a sliding scale on where do you want it placed? Incident versus geographic area. So if you want the weighting to be higher, so it places the new resource or new station in the area with the highest density of incidents, then you give this a higher score. And you'll see automatically the geographic reduces. So you can run this several different ways and see what the solutions come up with, but it allows you to set that parameter as well. And then you get a screen that sums everything up for you to make sure that you've made all the correct inputs, and then you click Optimize. And the application will work for a while, and because, remember all the things it's considering. It's looking at the stations, it's looking at the streets, it's looking at incident volumes in each of these zones, and what type of incident grouping you're asking it to optimize on. It may take 20 minutes, it may take a few hours, and you will have a new scenario with new scores and the location of where the new unit is placed at an existing station, or as this example shows, a new station location. So that is the power of Optimizer. Any questions on that?
One question.
Sure.
If you were trying to convince the council this is the best location for the station, they said, well, we can't afford that plot or it's not available. What's the second to that? Is there a way to run this where you get like a 1, 2, 3? Or
Yes. So in fact, that's a great question. This is an example of a presentation that we did for a client who had several different locations. This represents the base, their current deployment, versus opt means this is the location that Optimizer chose. And then this is a candidate location 1 and 2. So yes, it can, typically what happens is Optimizer will find the best location and then will say what's possible to purchase in that general vicinity. You find whatever is closest, we place the station there, and then run and see the output. And how does it differ very greatly from the optimal location, or is it still pretty close? Then what you can do is just kind of compare the results and see what you think you'd like. So does that kind of answer your question? The other way to do it, because we have had clients say, well, give me your first, second, and third choice. And it's a little bit more complicated proposition than you might think, because Optimizer is built to find the best solution. So then we've talked about, well, what if we put a station there and then find the next solution? Well, that's not really answering the question, because then you already have a station there, and then it's not giving you a true representation. We did find a workaround for it, and we did get the solution, but it's a more complicated process where we had to put dummy stations right next to the existing stations. So we did find it, but it takes a bit. So this is an example of a client who had multiple different options that they were evaluating, and how we put it together in a story map for them to kind of tell the story. This is, so the whole story behind this one is they had projected workloads, and they had several station locations that they were going to look at. So I'll do some real fun stuff here for you, give you some excitement. So we put this together on a story map, and you can see as I slide the bar, we have circled here the workload changes between the base and the projected workloads. So we worked with the client to say, all right, here are the incident type groups, here are the current workloads, and these are the projected workloads that we put into the analysis for them. And then the sliding bar just kind of shows you what the difference is between each of those. Okay, I sometimes lose my bar. Okay, you can see lower workloads, and these are the projected. And again, showing you how we used the runs per day and availability to provide all of the data in one quick and easy format here to look at. And then also showing the base versus the optimized scenario and what that looks like when you slide the bar. Let me turn that off. And candidate 1 versus candidate 2. It's kind of the same thing. But then we have all of the scores here so that we could see there is, so it was 1 second or 0.08 second reduction, and then this was 0.07. It was pretty darn close. So depending on the cost of each of these station locations, it was pretty close, except for the percent compliance was a little bit different. So if the weighting of the decision was on percent compliance, then the South Highland Avenue and Cherry Avenue was the best choice. Okay. So we also had a client who was looking at adding in a new station, but they knew a new development was coming in shortly after that. So their question to us was, if we don't plan for this future development, are we going to build a station and then already be behind the curve, because this could potentially draw a lot of workload for us that we aren't planning for because we don't see it today? So what we did, and hopefully you can see this, in this pink area here, that's their current situation. There are very little roads, and there are no incidents. All these green dots are incidents. There are none here. So what we did was worked with them to figure out what is an existing development that is very similar to the one that's going to be built here, kind of in no man's land. So they knew it was a 55 plus, and so that's why they were a little bit even more concerned, because typically they get more medical calls for those. So they found an existing development that was pretty equal in size. We can also do multiplication factors or division. So if you have something that's an equal mix of maybe commercial and or retail and residential, find one that's about the same mix, and if it's smaller or larger, we can multiply or divide accordingly to find the right mix of incidents that would go along with the development of that type. So we agreed that we would add in a total incident count, and this is how we would align or segment out those incidents. Most of them were going to be EMS high calls. and then what zones we were going to attribute that workload volume to. And moving down here, we also helped them build in some streets, because this is a new development, there was nothing there. So we helped them to put some street connectivity into that area so that we could do a proper analysis with routing into those incidents. And then the last slide here shows what the application came up with a new fire station there, the new workload volume, and an engine and a rescue at that station that they were planning to build. And the answer that we were able to tell them is that they were still going to get a 2-second improvement in their first engine response time, even with the new development there. So they were able to have some insight into what might happen when they build that station, and they have the new development coming up very shortly. So any questions on that? Okay. All right, so new features. Again, how many already have Atom? CAD analyst? Okay, all right. So installer. Our installer now has some built-in features that will allow you to check for prerequisites. So if you're putting this application on a new computer, it will automatically check to make sure the prerequisites are there and let you know what you need. We've put in better messaging for how to use the unit manager. So it used to be you would click on create a new unit, and then you would be left to wonder what to do next. We all knew as Deccan2018, but sometimes clients would be like, well, what do I do next? So now there's a prompt that says, all right, please click on a station where you would like to add a unit. So, and better messaging about how to save scenarios, and when an analysis is running, so that the client knows that something is happening, and you don't have to click the button again. So Unit Manager also has some improvements, and for those of you who have used the application, these will be big ones. Change and modify a station name. So you can maybe imagine that if you had multiple different station locations here, and they all said new, and then a big long line of numbers, and the numbers were a little bit different, it might be hard to go to City Council when you're probably using some internal terminology for all of these locations. You know, the Sky Harbor location, or locations, whatever. So the application now has the ability to change the station name, so it's going to go along with all the internal nomenclature that you're using to describe these station location names. Close an existing station. It used to be that you just emptied out the stations, and that was essentially closing a station, but again, probably really hard for City Council to believe that that dot on the map wasn't impacting the scores you're telling me that we're going to get. So you can now close the station and move an existing station. So those are some extra flexibilities that we have within the Unit Manager. All right. And then there's one additional huge feature that we have called VSR. Anyone know what VSR stands for? Variably staffed resource. Okay. So what this allows you to do is for departments out there that have units that are running and not 24 hours at a time, you have the ability to put a schedule along with a particular unit and change that schedule and see what the impact is. So as an example, I can click on any one of these units. I clicked on M6, and now I see the schedule for this particular unit, and I can modify and change it accordingly. Take days off, or change the hours. So adding in the variably staffed units for those of you either looking at putting units in for non-24, or you already are and you've been struggling to manage it, we can add in that VSR module for you.
So can you run a scenario where you run a frequency schedule, so 5 times
Yeah, we can do something like that. Like, well, you could do something like that before, but it would have required a lot of like manual work on our end to put the scenarios together. So this just simplifies the process where it's easy. You can click a few buttons. Yeah.
15 different scenarios. I'm only looking for one, but I can run it myself.
Right.
Right,
Exactly. Yeah.
exactly.
This just simplifies the process and makes it much less painful.
We can change the apparatus layer. I guess I've already closed with the big one. Changing the apparatus layer so that what you see on the map, maybe you don't like diamonds to indicate that those are your engines. Maybe you want to have an actual truck or engine-looking apparatus, so it's easier for you to see what are at all of your stations. So that is also an improvement within the application that we have that's available. All of these things are available right now. You don't have to wait. Okay, so questions on? Oh, yeah, please.
So I know through all of it you can see impacts of human time and put that back to the scenario. If I take away a truck at a station 24 hours and put it back there 7 days a week during my peak times, can I then look at my projections of off-peak times to see what kind of a workload I'm going to leave on the units that are remaining at the station?
Yeah. So what it does is, well, just to get a little technical. So once you do that, it's going to break that 24/7 scenario into those constituent time periods, and then it'll run each of those time periods like back to back, and then it'll aggregate scores afterwards. So you're going to have access to the entire aggregated scenario, which is your 24/7, and then you're going to have access to your time periods, which could be like 14/7 and 10/7, and you can look at each of them separately.
Thank you, Brian. He's definitely the variably staffed resource expert.
We're pretty proud of it.
Yeah. Great. Any other questions? You guys have been a pretty quiet audience. I hope that you've been tracking along with me. Oh, go ahead.
There was a mention of apartments that you'd be able to upload this to the Arcus online.
Oh, yeah. That's going to be... So I think that the export into ArcGIS Online was something that is coming.
Yeah, that's a work in.
Here.
Were you referring to the one that was during the presentation?
That Yiting
That's
did?
yeah. That's a work in progress. But we basically have the prototype built with Rochester, and we're trying to implement that into the core application. So
I do think that I heard that the timeline is this year yet, right?
Yeah.
I think that's what I heard. Don't quote me, but I think that is what I heard in that presentation. Okay.
Yeah, we just have to like work in the pipeline that goes from the desktop application to ArcGIS Online. So that's just the main engineering task we have ahead of us.
Okay. So any other questions? Any other scenarios that you are working on that you wonder how you would put into Atom and get the answer out? No? You're all experts already. Awesome. Oh, yes. Chad, please. No, not, so I think the opposite was true. Yesterday we talked about, in the Live Mum session, what happens if you take units out of deployment and what happens to the response times. And we said, yes, in Live Mum you can go in static mode and take units out of your deployment to see where you would have then gaps in your coverage and see what move-ups you might want to plan for the next day, like taking units out for training, finding out where the gaps, and say, okay, we're going to have a huge hole up here, so let's proactively move this person up, or no, as soon as they get on shift, they need to move up. And then we talked about the fact that Atom is the better tool to find out if you needed to, what is the actual response time impact by taking units out of the deployment. Great question.
And just elaborate a little bit about, I guess, what goes on in the office. So we collaborate, the Atom team and the MUM team sometimes collaborate especially when it comes to mapping stuff. But in general, the two teams, we operate pretty independently.
Yeah.
Select multiple instance types and run programs together, like iOS first and iOS first, and run that together?
You can, yes. So you can pull reporting on any group of incident types that you have built into to the application for CAD Analyst. And remember, CAD Analyst, again, is there's no predictive element to CAD Analyst at all. But if you wanted to pull a report based on incident type groups, they are all here, and you can mix and match and say, you know what, I want to run a report on how we're performing on all fire calls. Oh, okay.
Say I want to place a unit in service, ALS suppression.
Oh, I see.
The first thing on the ALS response and also on I want to see how the benefit is rescue and suppression.
Yes, so so I'll answer in the two possible questions I think you might be asking. So when we do an optimization, we have to choose one criteria to optimize on. So yeah, however, in the score sheet, when you get the answer, you do get the benefit of knowing, oops, sorry, that's not the one. You do get the benefit of knowing how that impacts all of your capabilities. So this is the results for one scenario. So we were looking at first engine dispatch to on-scene, but we also see the scores for all of the criteria. So it does tell you how one change impacts all of the capabilities, but you can only optimize on one at a time.
Yeah.
Yeah. Sure, yeah.
Yeah, it'll save them as scenarios.
Yeah, you can do a scenario comparison. You can look at this data sheet to find out what the differences are in all the scores.
Sorry, Robin, I'm going to jump in. So just going back to the first question, were you referring to if you want to, let's say if you wanted to add an engine and you wanted to optimize it on both structure fire calls and rescue calls at the same time? Yeah, so in that case, we can do something like that too with the incident type like groupings. So going back to the application. So for example, the way it's built right now in this demo application, we split up all the EMS incidents into Alpha, Bravo, Charlie, Delta, and Echo.
Wait, there's more. Wait, there's more. There's multi-ITGs in here.
Yeah, exactly.
Okay.
So what we can also do is, if you wanted to look at all of the EMS incidents, we can aggregate all 5 of them and create another incident type group on top of that. And we can do it in any number of combinations that you want.
So as an example, this is what Brian is talking about, where we have each of them split out into their own category. Then we're saying, here's your response on all combined medical calls. So if that's also something you wanted to put in your decision-making toolkit, you have that ability too. Great questions. All right. So, okay, well, are you sure there's no more questions? We've answered everything. You've come all this way. I don't want you to leave without feeling like you've been totally satisfied with your knowledge of how ADAM works and how it can be a reliable decision-making tool for you. So, excellent. Well, then I will let you all go, and thank you so much for your time, and we'll see you later tonight. Thank you.